Okay, it is time for another test. We got the transistors in, we got the necessary capacitors replaced, and remember we did our test earlier, so we know we don't have to worry about problems with DC offset because it's okay right now. We still don't know the bias and things because we haven't even gotten into the alignment, but we just want to test it and make sure it works at least as good as it did before, if not better. So I'm going to turn the volume up a little bit. I'm going to start a YouTube safe song. This is called the DeLong Incident. The DeLong Incident. Not bad. Sounds pretty good. I like it. So that's good. We pretty much have this thing mostly completed, and now we can look at the alignments. Now let's talk a little bit about that. The first thing when it comes to the alignment, if you're new to this, if you don't have a lot of equipment, we're doing our minimalist thing here on this video, you're really not going to be able to do a lot with the tuner section. And you probably don't need to, because with this vintage of solid state gear, unless you replace a component or unless somebody has moved or touched or adjusted something, the alignments typically do not go out. They stay pretty good. Very rarely you'll see something with the discriminator for the FM section. That one adjustment will go off a little bit and you may not be able to pick up stereo, or your FM tuning centering meter, if you have one, well, when you're on the station, you can hear that you're clearly on the station. The needle will be a little bit off. A lot of times that's an indication of that. That's the only thing that will sometimes drift a wee little bit, and that's rare that that happens. So to sum up, tuner section we're not going to worry about. The controls on this, you've seen me clean controls. I've done videos on cleaning controls. I'm not going to do that. These controls really don't need cleaned. I haven't heard any kind of scratchiness or anything, and they have not been cleaned, by the way. These are, I can tell they've never been sprayed or anything. I can still feel that friction grease in here, so it has that nice smooth feel to it, and it's not real loose turning. I'm not going to mess with it unless I have to. Now, in the event that you need to clean the controls, go back and watch some of my other videos where I do that. But really it just entails pulling the knobs off, and they're just friction fit. 4 screws, you have 2 on the top, 2 on the bottom. Faceplate comes off, and then you can get to the controls on the other side and just put a little drop of, you just put a little shot of the CRC residue-free cleaner in there, and then follow up with a tiny little drop of Deoxit Fader Lube, the F5. The green stuff, not the red stuff. And it'll be good to go for a very long time. That's it. Let's look at what's involved in the alignment now of the amplifier. Okay, looking at the adjustments section on here, you can see that when you get into the tuner, that can be quite involved. So right here they're talking about changing the spacing on the rotor blades on the tuning gang capacitor. Again, all of these things are done at the factory, and unless somebody actually moved them, don't mess with it, because if you bend one of these in such a manner that it contacts the stator plates, it'll short it out, and then the tuner won't work. So again, don't mess with it unless it really needs it. Moving along, you can see some of the connections you have to make and some of the test equipment that's required to do this properly by the book. You know, you need an AC voltmeter, you need a distortion analyzer, an oscilloscope, a multiplex signal generator, a standard FM signal generator, RF generator. You need the proper adapters so that you get the correct coupling between your test equipment and your device under test. And I did a video on that. You can go back and look. And And then you can see all the alignment points that there are. And if you really don't understand what they're talking about, they're really assuming when they tell you this stuff that you know what they're talking about. So they don't go into great details. They tell you about dB settings, and that can be a little bit deceiving because dB has to be referenced to something. You know, is it a dB watt? Is it dB versus volt? Is it dB versus microvolt? All of these things are very important. I suggest you learn more about that before you would get into that. So what we're going to, and then even the AM section, you can see what it gets into. We're going to look at this part. And on this amplifier, it is extraordinarily simple. If you go another model up from this, you know, to maybe the 3700, I think it is, there will be some extra adjustments. On this one, you really don't have potentiometers. Like for instance, on a normal or on the higher end ones, you would actually have a bias pot to set your bias idle current level, and then you would have a DC offset pot. And I'll show you on the schematic kind of generally where that type of thing would be. So you have your differential pair, your input, and your DC offset would be down in here somewhere. And what that would do is that would ensure that with no signal you have 0 volts here. You don't want any voltage going into your amplifier section. You want it to be nulled out. Now these are all carefully chosen components, and it will be very close, but you'll notice that these lower end receivers will always have a little bit of DC offset on them, you know, like 30 to 50 millivolts. Whereas with ones that have an adjustable pot, you can adjust them right down to just about 0 volts, right on the money. That doesn't really hurt anything. There's a lot of arguments over distortion and that, but honestly, look at the specs on this thing. Even with that, this thing's outputting its rated power at 0.05% THD. Now, I would say that if you read the distortion at extraordinarily low levels, you might be able to measure it with test equipment. But again, hearing it in your ears, probably not. At least not my ears. The other thing is when we get up to the bias splitting section, and they don't have the diodes and things, but if you look here, here's your bias circuit. And these are 2 channels, so you have your right and left channel. But if you look down here, I'll zoom you in a little bit. See this little curved line here? That's a jumper that can be removed. So you have 2 resistors that are in parallel. So you have 2 bias setting points that you can choose from. If you cut the jumper out, then it will only use this one resistor. If you put the jumper in, it will parallel this resistor and it will increase your bias current a little bit. So normally there would be some diodes in here to provide a constant voltage drop, and then you would fine tune it with a potentiometer. On this one, it's strictly relying on these resistor dividers and having 1 jumper. So it turns out to be, if it's within a certain range, you leave the jumper in. If it's out of range, you can take the jumper out, bring it up a little bit. That's all. That's the only choice you have. So I can tell you when we read the instructions, that's what it's going to tell you to do, is measure the bias voltage, which you're going to measure it across this resistor here, one of these emitter resistors, and then you're going to look for a certain amount of millivolts. It's usually in millivolts, and if it's within range, you leave it alone. If it's out of range, you cut the jumper and see if it gets better. If it doesn't get better, then you put the jumper back in and you troubleshoot it. And what will end up happening is you'll either find a resistor will be bad, or one of the transistors may be leaky, or the gain might be out of spec or something. You have to replace a transistor. So let's take a look at that. First thing it says is turn the volume down to minimum, turn the amp on, wait about 10 minutes. Now I'll also add to that, if you have it down to minimum, I would also remove any connections from the back. So in case there's any noise coming in, you know, from an external source, you won't have that. So nothing plugged into the receiver, set to auxiliary, volume all the way down, and we're going to connect a DC voltmeter to the test point terminals, T1 for left channel, T2 for right channel. You can see they're showing the test points right here. So there's the heat sink, here's your 4 output transistors, and here's your test points. Okay, so they want T1 and T2 for the left channel and T3 and T4 for the right channel. And they have a pretty wide margin of error, don't they? It has to be between 10 and 100 millivolts. Now, if you look at a higher end amp that's adjustable, they'll tell you to adjust it to, let's say, 50 millivolts or 30 millivolts, plus or minus 5 millivolts. So they have a lot tighter spec. They're leaving the spec pretty loose on this. Now, is that going to hurt anything? No, it's not. The only thing negative of it is if you're running 100 millivolts or a little bit higher, the amplifier will idle a little bit hotter, meaning the heat sink on the output transistors, this thing right here, will get a little bit warm to the touch because the amplifier is dissipating more current, more quiescent current when it's sitting idle and there's no signal on it. You don't really need that. It's not gaining anything for you. If it's not high enough, if it's lower than 10 millivolts, the transistors are pretty much turned off. And that's where you can start hearing that crossover distortion that we've talked about in other videos. So it's kind of a balance. So all they're saying is make sure it's in here. Let's do it. Okay, we have our trusty little meter and it's set to DC millivolts. And we're going to go down in here and connect to the 2 test points. Here's our first test point. Our second test point. And if we look, we only have about 6.3 millivolts. Okay? That's a little bit lower than 10. So what they're saying is if the voltage is less than 10 millivolts, cut the jumper. Okay? So theoretically, I should cut the jumper on this. I'm going to do that because I want you to see what it does. Okay? Okay, it is quite difficult to see where this is. But if you look, here's the fuse holder. And if you come straight back from the fuse holder, right there, I'm touching it, there is a jumper. You'll have to trust me on it. But there is a jumper right there that we're touching. See it? If I could move my thumb out of the way, there it is. They want you to cut that. Now it's easier to see on the other channel. So I'll move you over to the other channel because it's out in the open. And if you look at the one on the other channel, it is right here. And see what they've done? They've put a little slot in the circuit board there. And you can actually go in from the back and cut that with a set of wire snips, or you can actually heat it up from the back and push one of the leads up out. And that's what we're going to do. So I'm going to unplug this thing, make sure everything's unplugged. And we're going to flip this thing up like so. And here's our 2 jumpers. And you can see right there's the first one. So again, we're going to get our trusty solder wick and we're going to go right over to that pin and clean the tip on my cruddy iron here. And we're just going to remove all the solder from there. All right, just like so. And then I'm just going to take a little screwdriver. I'm going to just push that wire up out of there. Like so. See that? And now it's gone. And then just because I am picky that way. I will take a cotton swab again, and I'll just clean off all that flux and crud, and it'll be ready if we need to ever put it back in. And you can just leave it like that. It's not going to hurt anything. Leave the other end in. That way the next person, if they need to put it back in or something, it's there. All right, take a look. And you can see that it's just kind of sitting up right here. We'll get it up out of the way. And it's out of our way now. And if we need to put it back in there, it's easy enough to just pop it back in. Okay, it's not going to hurt anything. And there we go. All right, let's hook our meter back up and see what that does. Okay, we now have the amplifier plugged back in and turned on. We have the meter connected. And look at that. We are now in much better condition than we were. And I just turned this amp on about a minute ago. So what you're going to notice is, as this before when we tested it, it had been on for a while and we were listening to it. Do you remember? And it was probably lower than that 6 millivolts before. But you're going to see this is going to drift up, and it's probably going to settle down somewhere around 20 to 25 milliamps, which is right in that sweet spot that's higher than 10 milliamps and lower than 100. So this is going to take about 10 or 15 minutes to stabilize. I'm going to let it sit there, and we'll come back once it's done warming up. Okay, just like I said, we're somewhere in that 20 to 25 millivolt range. And that's good. And it'll sit here and it'll kind of drift up and down now as it's sitting here, which is good. Now, why do we care about this? Well, believe it or not, this idle current, or this bias current that we're looking at, and we're actually looking at a voltage that represents the current, but it's going to affect the low volume performance more than it is at high volumes. In other words, when we're listening to this amplifier just at a whisper, very quietly, this is where you notice your bias setting the most, if it's set too low. If it's set too high, it really doesn't make much difference. But if it's set too low, you technically could hear a little bit of distortion at very, very low volume. So if you're in an enclosed area in like a small apartment or a small bedroom, and you're very close to your speakers and you don't listen to it very loud, maybe you're listening to something at night or something when you're relaxing, you can actually hear a little bit of distortion if this is set too low. So that's why we worry about it. So you can see it's floating around here, it's happy. Let's look over at the other channel now and see what it looks like. Okay, so we'll take this off. We move it over to here. Just like so. And we can see, same thing. This one's a little bit low also. So we're going to do the same thing to this one, and we're going to remove the jumper and see how it turns out. Okay, jumper is out. Amplifier is on and starting to warm up. And this one's a little closer to being at the bottom of spec. But again, it's still creeping up a little bit. So I think it's still got a couple more minutes before it stabilizes. But once again, it's going to be really well within that range where you want it to be. So that's it. And of course, we checked the DC offset. They don't even have you check that on this one, but it should be close to, again, 0 volts. And of course, when we checked it, it was. Now, could we have left that as it is? Yes, we absolutely could have. Probably if we had driven the amp hard for a while and heated up the heat sinks and then turned the volume down, you would be well above that 10 millivolts. But if you're listening to it at low volumes, if you just want to turn it on and listen to it, it's better off where it was. And am I making a mountain out of a molehill? Yes, I am. But these are the little details that you can focus on and kind of think about how all this stuff works. Okay, because everything, all of these things make a difference. They add up whenever you're working on these things. Okay, the last thing we're going to do on our alignment is the output indicator adjustment. So those are the power meters, that reads the watts. And this procedure is very common to a lot of the receivers of this generation that have power meters, how to calibrate it. All of them have you feed a fixed signal into the input of the auxiliary jacks and then set the volume till you read a certain voltage, AC voltage, across a dummy load. And then you're going to set the meter to read a certain wattage based upon that voltage. And it's all Ohm's law. So how do they come up with this number? Well, watts equals, if you take the volts squared, voltage squared, and divide that by the resistance, that'll tell you your watts. So again, they're looking for 20 watts. So if we do the math on this, if you take 12.6 and you square it, this doesn't have a square button on it, so, and then you divide that by 8 ohms, it gives you roughly 20 watts or 19.8 watts. So that's all they're trying to do, is they're trying to get you to set this at a 1 kilohertz signal. Now, here's where it gets kind of optional. Remember, we're doing a minimalist video here, using the least amount of test equipment. Of course, we have hand tools and soldering tools and things, but we're using minimal test equipment because that's really the expensive stuff. So what we're going to use here is just a simple audio generator, and you can get these. It doesn't have to be this fancy of one. You can get used ones on on eBay or whatever. You can buy brand new ones. They even have little kits you can buy, little tiny ones that will output a sine wave, in the audio frequency spectrum, and they're very, very inexpensive. So we're just going to use this one. I've had this forever. It's one of the early pieces of equipment that I bought a long time ago. And we can select sine wave, which is what we have here with the button out. We're going to set the scale times 100. So if you take 100 times 10, that's going to be 1000 or 1 kilohertz. And then the attenuator is just gets you in what range this amplitude pot's going to work. Now, here's the thing. Looking at the instructions, they want a 1 kilohertz tone, so we're going to set this right around 1 kilohertz. So 10 times 100. And this isn't super critical, so if it's not exactly 1 kilohertz, it doesn't really matter. And we're going to set it for 150 millivolts. So we want 150, when they say 150 millivolts, they're talking 150 millivolts AC RMS, okay, or root mean squared. That's how we measure AC voltage when they just say that in the instructions. So we're going to just put a couple of jumper wires in there. We're going to connect it to our trusty little multimeter. I'm going to turn it on. We're going to turn the test equipment on here. And we're going to measure the AC voltage. And remember, we want 150 millivolts, which is 0.150. So I'm going to take this, hopefully we're in the right range. We're going to turn this up till it says 150. And we just want to get it close. There we go. 150 millivolts. Give or take, huh? There we go. Okay, so now we have the correct signal, and you have to get the little adapter connectors that can give you what you need. Now, you can just use something as simple as, a set of banana plugs on this end and an RCA plug on the other end. Like, you can take one of these patch cords and you can cut the end off of one end and just put the wires in these binding posts in this case, and then the other end leave the RCA on it and you could plug it in. You can get something fancy where you can get one of these little adapters. You can order these on eBay, banana plug to BNC adapter. And then you can take another, again, your RCA patch cord without having to cut anything off of it. And we can take one of these little RCA to BNC adapters. Or we can just order a cord from Amazon or eBay or someplace. And we connect that in. And this can go to your auxiliary in jack. Now, the only problem with this is we're only going to feed one channel, which is fine. You can do the right channel and then move over and do the left channel. And that's what we're going to do here. You could also get fancy and use a Y adapter and plug it into plug it into both channels at once. For this particular test, it's not important. All we care about is we can drive each channel to the wattage that we need. Now, the other thing it says is they want us to connect an 8 ohm resistor and an AC voltmeter to the speaker terminals. So what we're going to use is a couple of these little resistors. Now, this is the cheapest one you can get, these little ceramic 20 watts. These are very, very inexpensive online. Okay. Now, if you want to step up from that, they make metal resistors, and they make them 25 watt, 50 watt, 100 watt, and you can even get really fancy, and they have gigantic ones that are 300 watt. Okay, so all I did was I ordered a couple of these on eBay. These resistors really only cost, maybe $10 each or $20 each, something like that. They weren't very expensive. And I just mounted them to a piece of aluminum extrusion that I got at a local metal store, like that sells like machining supplies and things like that. It's a hardware place, kind of. And I just mounted them as a heat sink and then just attached some wires. So we can use this as the dummy load, but we're just going to use the little ones. They're only rated at 20 watts. So when we drive 20 watts into this thing to test it, these are going to get really, really hot, really, really fast. So we want to adjust it pretty quickly. You normally would want about at least double the wattage that you're going to put into it. So for instance, since we're going to test 20 watts, you would want like a 50 watt resistor or whatever. So, but we're going to use these just to show that they do work if you're just powering it up for short term. Okay, we have remember we used our meter to set our 150 millivolts output, and we set it to roughly 1 kilohertz. And then we have our little adapter plug going to our RCA jack, and it plugs right over to the back of here. You can see it, and that's the first channel of the amplifier, of the auxiliary input. We have it set to auxiliary, and we have the volume all the way down, amplifier's turned off, and you can see I have two resistors, those two resistors, and they're just, I stuck some wires on them, and I put them in the right and left channels. I'm going to leave these in the back here where they're out of the way, and I have my meter connected across the first one here. All right. So we're going to turn the meter on, and we're going to turn the amplifier on, and we're going to set it just like they say. Okay, let's go over the procedure before we do it. We're going to set the control to the flat position, so everything's flat. We are going to set the speaker selector to A, and we're connected to the A speaker terminals. We have our resistors connected. Set the function switch to auxiliary. We have our 1 kilohertz set to 150 millivolts. And then you adjust the volume control so the voltage reads 12.6 volts, which is 20 watts AC. All right. and they want you to set these two pots, VR1 and VR2, for left and right. And you can see them right here, VR1 and VR2, and it even says right channel, left channel. We're going to set those until the 40-watt meter just shuts off, okay? Because you can see it jumps from 5 watts to 40 watts. And just so you see, I have the stereo mono switch here. See there? Set to mono. If I turn this off, only one channel is going to drive now. See that? And I'm actually connected on the wrong channel here with my... Let me move this over. But you can set it to mono, and then one channel will drive, or it'll drive both channels off of the one input. So, and again, we go here, and this is the right channel. And this channel's off, see? That should be 12.6, and it's actually reading 14.9. So we're going to have to adjust that side a little bit. So let's set this. We're on right channel. I'm going to turn this to 12.6. Hopefully not roast our resistor too much. Okay. 12.7, how's that? Pretty close. And there, right there is where it's turning on and off. I don't want to leave this up too long. There. Okay. That channel is set. Now I'm going to move over to the other channel. And like I said, we could set this to mono also if we wanted to. But this kind of checks each individual channel. I just wanted to show you how you could set that to mono and get both channels driven with one input. Okay, now we're going to look at this upper one, and remember, it looked pretty good. So, and it would help if I moved my meter over to the other resistor, huh? And these are getting pretty toasty. Well, at least the one that we're driving is. Okay, here we go. Turn this back up. And we're going to drive this up to 12.6 as well. And right there's 12.6 roughly. And we're going to get on this one. And we're going to adjust it till it just turns on and off. There we go. Okay. That's it. Meters are set. They were off just by the tiniest little bit, but that's all you do. But really, it wasn't about the meters. It was about showing you how we can calculate wattage with something as simple as some resistors and your multimeter. Okay, the main reason that I wanted to do this was not for the meter calibration. Of course, that shows you that, but you saw I was very close. But really, I wanted to kind of show you how you can just use this simple meter to measure wattage of your amplifier by using a couple of resistors like these. So for instance, we have these little ceramic jobs here, and by measuring the AC voltage across that load. So remember, all you do is take your voltage that you read here, square it, so the voltage times itself, and then divide it by the resistance. So let's say we had 10 volts on there, okay? 10 times 10 is 100, right? Or 10 squared is 100. And divide it by 8 ohms resistance would be 12.5 watts. So if I wanted to set this to 12.5 watts across an 8 ohm load, I would set it to 10 volts. So we just turn this up right till it says 10 volts. Now, of course, this doesn't show distortion or anything like that, but it does give us an idea of if we can get how much wattage we can get out of here. The thing that we can't do is we can't measure the clipping. All right. Now the other thing, let's work backwards. Let's look at our meter. If we have 1 watt, so here's 1 watt. Okay, that says 1 watt. 1 watt. So we go, turn this on. If we take 1 watt times the 8 ohms, okay, and we take the square root of that, right? That's what we want to do. So we go square root of the 8. .82 volts. And look what we have, 2.8 volts. You see that? So those are your two math formulas, okay? So if you take the wattage and you times it by the resistance, so watts times resistance, and then you take the square root of that, or square root of PR, that's going to equal your voltage. Does that make sense? Very good. And I'll put those up on the screen, those two formulas, so that you can check watts from volts, and you can check the volts from the watts across your resistive dummy load. Okay, let's sum it all up here. And let me put a little barrier up so we don't get confused on all this stuff here, right? Because these things in the background are just backdrop. We don't count this. Right here on the bench is all we really need to get started with working on simple receivers like what we just worked on. So you need some basic hand tools, some solder wick, some solder, a good soldering iron, our little homemade dim bulb tester, a multimeter, and this one's nice because it can actually check amps as well. You can clamp this over a wire and measure current non-invasively, but you can also use like a low-cost multimeter like this, a little more traditional one. These are all in the $30 to $40 range, maybe a little more. They have different features. This one I like, but the only thing that it does not have, it has everything you could think of on it that you would need for the basics, except for a frequency meter. And this one can actually measure frequency up to a certain range. None of them read real high frequency, but in the audio spectrum, you can read frequency by hitting the Hertz button. Something to keep in mind. They do make these little units. You can get a little nicer model that will measure frequency and things, but these are really good. We used some basic 8 ohm resistors. Notice these ones say non-ind, IND. That stands for non-inductive. In other words, you don't want a resistor that's wound up in a coil, like some of the wire wound resistors. Some of them are inductive, and they can have a slight effect on the audio output, especially at higher frequencies when you get up to that 20 kilohertz range. Most of them will not do that, but most of the resistors that you would buy on eBay or Amazon or something, the 8 ohm dummy load resistors, they're very inexpensive. Almost all of them are non-inductive like this, or very low inductance. So don't worry about it. You need this little patch cord to, if you're going to use a signal generator, and it's not here yet. And of course, a couple sets of leads. You want normal leads, and I like these little test hook leads. Again, you can order these on all the various haunts. They're not real expensive. You can get cheap ones, you can get high quality ones, doesn't matter, they all work. And you'll certainly want a few crocodile or alligator clip leads, whatever you want to call them, jumper leads. And that's it. And then we'll have this one option would be an audio signal generator. And again, there are different versions of those. You can get real fancy, expensive ones, or you can get, you know, very inexpensive little ones that you can buy as a kit and build them. Just watch some of the ones you buy, like that are only a few dollars on eBay, that are just a plain circuit board with some knobs. Some of those do not work very well, especially with the sine wave. The sine waves are not very clean on them or anything, but they do work. I mean, in a pinch, they'll work for you. And then they have low-cost actual, you know, signal generators that you can buy too, and they'll actually go up. Some of them will even go up into the RF frequencies, and some of them can even do some basic AM modulation. Just what you want to spend on them. But that's it. Now, of course, we can get into all kinds of crazy things. We can get into oscilloscopes and, you know, all kinds of fancy test equipment. You don't need that right now. All you need is what you saw. And one thing else I could throw in would be a desoldering pump, because these are just a couple dollars online, and they help removing solder off the board as well. That's it. And I don't know, this is, other than a signal generator, this would be your most expensive tool. And like I said, expect to spend $30 to $50 on a good one, or a good enough one. The rest of these things, you know, you can buy this at a hardware store, you know, for 10 or 15 bucks. The hand tools, you can buy cheap ones or expensive ones, but a screwdriver still turns screws. If it's a 99-cent one or if it's a $20 one, they all work pretty much for what we're going to do. So that's it. I hope you enjoyed this video. It was a lot of fun for me to do. I did the minimal service that you would do, not the bare minimal, but a good compromise of the things that you should replace and the things that you don't need to replace, the basic calibrations. And of course, I did not get into the tuner on this. I did that on purpose. You can connect an antenna to this and make sure that it can receive stations, AM and FM. I did a lot of videos on that. You can go back and look through that when you're ready for that part of it. And I didn't get a whole lot into tests like, you know, distortion and things like that, because I don't think it's really necessary for a beginner. That's kind of getting a little bit beyond down the road what you would want to do. And the other thing we mentioned but didn't do in this video is cleaning the potentiometers, because as I said previously, many videos that I have and that others have done that are very good on how to clean a potentiometer, how to spray them and so forth. So that's it. And as always, I wish you all peace, joy, happiness, and good health in your lives. And hope to see you again real soon with the next thing on the bench. And we'll see. I'm still deciding which one I want to put up here next and what I want to do. So until then, stay well. We'll see you soon. Bye-bye.